Hello, welcome to another exciting edition of Physics with Chris. In today's lesson, we are looking at coefficient of friction also. But in this class, we are looking at coefficient of friction of an inclined plane. Coefficient of friction of an inclined plane. So what are the forces that will be acting on a body that is on an inclined plane? Consider a body on an inclined plane as shown above. Let's say there is an inclined plane. Let me redraw it like this. So there is an inclined plane. This is an inclined plane that is acting. This is a body acting on an inclined plane at an angle of theta to the horizontal. What are the forces that will be acting on this body? You have the normal reaction will be acting on the body against the weight of the body. The weight of the body will be acting downward, and there will be a normal reaction that will be acting against it. Then you have force parallel to the plane that will be acting upward. Then you have another force that will be acting downward, frictional force. So these are the forces that will be acting on this body. You have this force acting upward. Then there will be a force that will be acting downward. The weight of the body will be acting downward. Then you have the normal reaction that will be acting against it. According to Newton's third law of motion, for every action, there is an equal and opposite reaction. So there is a normal reaction acting against the weight of the body. And the weight of the body, W, is given by mg. Weight is mg, that's mass times acceleration due to gravity. And there will be force that will be acting downward also, frictional force. So how can we get the value of the forces that will be acting in all these directions? If I project this line vertically like this angle will be theta, will be equal to this angle. From geometry, this angle here will be equal to the angle that is here. And if I complete this triangle, this will be my 90. So if I bring this triangle out, this triangle like this, now if I bring it out in this place, this is what I have. So I have this body, and then you have this acting like this. So this is my 90, and this is my theta. Then it is like that. This is my mg, weight of the body, mg. So I need to find the force acting like this, then the force acting in this direction. This body, let me draw it to be big. You have something like this, then you have this. So this is 90 degree, and this place is my theta. So this place is my mg now, which is this line, which is this wmg, which is this one now, is this line. So I need to find this place, which will be my opposite, and this is opposite hypotenuse, and this place will be adjacent. So I need to find my opposite and adjacent in terms of this and this. And from a trigonometric ratio, you recall that sine theta is opposite over hypotenuse. So using sine theta is equal to opposite over hypotenuse, I have sine theta is equal to opposite over hypotenuse over mg. Then my opposite is over 1. If I cross multiply, my opposite will now be equal to mg sine theta. So my opposite is mg sine theta. So this place is mg sine theta. This place is mg sine theta, which is also equal to this line now. This place is equal to this line. If I complete this is a rectangle. So this place is equal to this place. So the force acting downward like this now, this force will be equal to mg sine theta, which will be equal to F, because upward force will be equal to downward force. For every action, there is an equal and opposite reaction. Then I need to get this place also. I recall from my trigonometric ratio that cos is equal to adjacent over hypotenuse. So I will have cos theta now is equal to adjacent, which is this side, over hypotenuse, which is mg. Then this over 1, if I cross multiply, my adjacent will be equal to mg cos theta. That means this adjacent, this side, is mg cos theta, and this side will be equal to this side. So in this place now, this place, the force acting like this is mg cos theta, which will be equal to the normal reaction acting against the body. So these are the forces that are acting on a body that is on an inclined plane, and all these expressions, they are needed when we want to solve questions on a body that is on an inclined plane to find either the coefficient of friction or any other thing on a body that is on an inclined plane. We look at more examples of coefficient of friction of a body that is on an inclined plane. But note that note that the coefficient of friction of a body on an inclined plane is given by mu is equal to tan theta. To get the coefficient of friction of a body that is acting on an inclined plane, you can just use tan theta. Tan of the angle that you are given is the coefficient of friction. I'll see you this equation when we are looking at example in our next episode. So stay tuned on this channel, Physics with Chris, because more exciting questions and answers are still coming. Thank you.